let's talk about principal roots. What does it mean when we say principal roots? The principal nth root of a number a is represented as the nth root of a, where n, also called as the index, is a positive integer greater than or equal to 2, and a is the radicand. So again, we have the nth root of a. The index here is represented by n, and this is the radical sign, while a is what we call radicand. The principal nth root of a positive number is the positive nth root, while the principal nth root of the negative number is the negative nth root if n is odd. If n or the index is even and the radicand is negative, the principal nth root is not defined. It means it does not exist. When the index is 2, it is usually omitted. So, for example, we have the square root of a, which is equal to a. 2 here, or the index 2, will be omitted. For example, we have 5 times 5. So, we multiplied 5 by itself. So, if we're going to write it using exponential method, we're going to have an exponent 2. And it will be read as 5 squared. So, the square root of 25 is 5 because 5 times 5 or 5 multiplied by itself is equal to 25. Next, 2 times 2 times another 2. Writing it in exponential form, we have 2 and then the exponent is 3, read as 2 cubed. Meaning to say, the cube root of 8 is 2 because 2 times 2 times another 2 or 2 cubed is equal to 8. So we have 3 multiplied by itself 4 times. We have 3 raised to the 4th power. The fourth root of 81 is 3 because 3 times 3 times 3 times another 3 is equal to 81. Now let's have the following. Let's find the square root of 81. In this example, the index is 2. Remember, when the index is 2, it will be omitted. So meaning to say, we're going to think of a number multiplied by itself will be equal to 81. And that is 9. Because 9 times 9 is equal to 81. Therefore, the square root of 81 is equal to 9. How about the cube root of negative 8? So let's have a number multiplied by itself thrice is equal to negative 8. And of course, that is negative 2. Negative 2 times negative 2 is positive 4. Times another negative 2, it is equal to negative 8. Therefore, the cube root of negative 8 is negative 2. How about the number multiplied by itself is equal to 0.36? And that is very good. It is 0.6. So 0.6 squared or 0.6 times another 0.6 is equal to 0.36. Therefore, the square root of 0.36 is equal to 0.6. Another, the fourth root of 625. The index here is 4, meaning to say, you're going to think of a number multiplied by itself 4 times will be equal to 625. And that is 5 or 5 to the 4th power. Let's see. 5 times another 5 is 25. 25 times 5 is 125. And 125 times another 5, it is equal to 625. Therefore, the fourth root of 625 is 5. Next, how about the cube root of the fraction 8 over 27? So you think of a rational number multiplied by itself thrice will be equal to 8 over 27. And that would be 2/3. So multiplying all the numerators, 2 times 2 times 2, it will be equal to 8. On the denominator, the product is 3 times 3 times 3, 27. Therefore, the cube root of 8 over 27 is 2/3. Next, how about the square root of -4? Can you think of any integer multiplied by itself is equal to -4? Positive 2 multiplied by itself, it is positive 4. Let's try -2. -2 multiplied by itself, it's still positive 4. Meaning to say, the root does not exist because there is no number when you multiply by itself will result to a negative number. Now, let's classify principal roots if it is a rational or an irrational number. So, to determine whether the principal root of a number is a rational or an irrational number, identify if the radicand is a perfect nth power of a number. If it is, then the root is rational. If not, the root is irrational. Let's have the first example. The square root of 49 is equal to 7. 49 has a perfect square root and that is 7. Therefore, the root is rational. The square root of 12. Getting the square root of 12, we're going to have 2 square root of 3. So where did we get 2? The factors of 12 are 4 times 3. And the square root of 4 is 2. 12 has no perfect square root, therefore, the root is irrational. Next, how about the cube root of 27? And it is 3. 27 has a perfect cube root, which is 3. Therefore, the root is rational. Next, let's have the cube root of 24. The factors of 24 are 8 times 3. And 8 has the cube root of 2. So the cube root of 24 is 2 cube root of 3. So 24 has no perfect cube. Therefore, the root is irrational. Okay, so let's talk about perfect square numbers. So I have here a table. So let's get the square of the numbers 1 up to 25. So we have the square of 1, which is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is equal to 25. 6 squared is 36. 7 squared is equal to 49. 8 squared is 64. 9 squared is equal to 81. 10 squared equals 100. 11 squared equals 121. 12 squared is 144. 13 squared is equal to 169. 14 squared is 196. 15 squared is 225. 16 squared equals 256. The square of 17 is 289. 18 squared is 324. The square of 19 is 361, while 20 multiplied by itself is 400. 21 squared is 441. 22 squared is 484. The square of 23 is 529. 24 squared is 576. And 25 multiplied by itself is equal to 625. All these numbers in red ink are what we call perfect square numbers. Let's talk about square root of a number between two integers. Let's determine between what two integers the square root of a number is. To do this, determine which two perfect squares the radicand falls between, then find the integers that represent the square roots of these perfect squares. Let's have the first example, the square root of 15. So 15 is between the perfect squares 9 and 16. The square root of 9 is less than the square root of 15, and the square root of 15 is less than the square root of 16. So the square root of 15 lies between the square root of 9 and 16, which means square root of 15 lies between the square root of 9 is 3 and the square root of 16 is 4. Therefore, the square root of 15 lies between 3 and 4. Next example, square root of 72. 72 is between the perfect squares 64 and 81. Meaning to say the square root of 72 lies between the square root of 64 and the square root of 81. The square root of 64 is equal to 8. The square root of 81 is 9. Therefore, the square root of 72 lies between 8 and 9. How about the square root of 264? 264 is between the perfect square 256 and 289, which means the square root of 264 lies between the square root of 256 and 289. The square root of 256 is 16 and the square root of 289 is 17. Therefore, the square root of 264 lies between the two integers which are 16 and 17.